Many of the application layer protocols in the TCP IP stack, we can identify them by a unique port number. Several different applications have what are referred to as well-known addresses. For example, if you're out surfing the web and you point your browser to a non-secure HTTP site, probably you're using TCP port 80. Let's take a look at how that communication flow would go on screen. We've got a client with an IP address of 10.1.1.1, and we're wanting to talk to a web server with an IP address of 172.16.1.2. When we send our packet over to that web server, notice the source IP address. It's the IP address of the client. The destination IP address, no surprise, that's the IP address of the web server. However, notice the ports. In addition to having a source and a destination IP address, we need to have a source and a destination port. And in this case, it's not labeled on screen, but for HTTP, it's going to be a TCP port as opposed to a UDP port. And the destination port going to the web service on that web server is port 80. That's a well-known port. The source port is 1248. That is not what is referred to as a well-known port. Instead, when we start a session with a remote web server in this case, we're going to be pointing to the well-known port of the service with which we're trying to communicate, but our source port is going to be a number that is above 1023. Port numbers greater than 1023 are referred to as ephemeral ports. Port numbers of 1023 and lower are referred to as well-known ports. So we're going to a well-known port, but what happens when the web server communicates back to us? The ports are transposed, and the source and the destination IP addresses, they're transposed as well. Now, coming back from the web server back to the browser on the client, the source is now the source IP address of the web server. The destination is the destination IP address of the client. And notice the source port, we're coming from the server. So the source port is 80, and we're going to a destination port of 1248. So that destination web server, it just transposed source and destination IP addresses and port numbers, and that gets us our two-way communication. And as we progress in our networking studies, it's important to be familiar with several of these applications that are going to be using well-known port numbers. And here's a collection of some of them that you might run into. Let's talk about these. If you're doing a file transfer, FTP, the file transfer protocol, is very common. Normally when we use FTP, we're going to be authenticating ourselves, providing username and password credentials. And you notice it says we're using TCP port 20 and 21. Port 21 is used to set up communication between our devices, and then port 20 is used for the data transfer. FTP is not secure, however. SSH, that's a way that we can remotely connect to a terminal session. Maybe we're connecting to a router or a switch, and we don't want someone eavesdropping in on our session. Well, Secure Shell can encrypt our traffic, so if it is captured, nobody's going to be able to interpret it, and that's going to use TCP port 22. Something else that's going to use TCP port 22 is SFTP, or Secure FTP. It's going to use an SSH session for file transfer. Yet another use of TCP port 22 is Secure Copy. This is similar to Secure FTP. However, we can get additional information about the file that's being transferred, such as the original date and time. Telnet, that's the non-secure version of Secure Shell. That's the way that we have traditionally connected to routers and switches to get a command line interface prompt, but now it's being recommended that we migrate away from Telnet and be using Secure Shell. And Telnet, it's going to use TCP port 23. Coming in at TCP port 25 is SMTP, the Simple Mail Transfer Protocol. We actually have multiple email protocols. SMTP is used for sending mail to an email server. We're going to use other protocols like POP3 or IMAP4 to retrieve, to download email from a server. DNS, the domain name system, running on either TCP or UDP port 53, is going to allow us to resolve a domain name like Cisco.com to a corresponding IP address. Another variant of FTP is TFTP, or Trivial File Transfer Protocol, using UDP port 69. It's going to be used for file transfer. It's not secure, and it doesn't even require authentication like FTP does. DHCP, the Dynamic Host Configuration Protocol, that's a very common way that a device like a PC can automatically obtain an IP address. And not just an IP address, but a subnet mask, a default gateway, the IP address of a DNS server, and a variety of other things could be assigned to an end station using DHCP. This information is coming from a DHCP server. We've already talked about surfing to a website using HTTP, and we said that was going to use TCP port 80 most commonly. POP3, that's a way to retrieve email. That stands for Post Office Protocol version 3, and it uses TCP port 110. NTP, the Network News Transport Protocol, at TCP port 119. That's going to allow us to access information from Usenet news servers out on the internet. At UDP port 123, we have the Network Time Protocol, or NTP, and by having all of our devices reference an NTP server, they can agree on time. There's a simplified version of NTP. It's Simple Network Time Protocol, same port, but the way it does its calculation for accurate time, it's a little less complex than NTP, and therefore it might be a little less accurate than NTP. Another email protocol, one that allows us to read messages from an email server at TCP port 143, is IMAP4, Internet Message Access Protocol version 4. You normally see IMAP4 used these days more than POP3. Typically, if you have a POP3 email client, that's going to download an entire message to your device, maybe to your laptop. And then when you try to read that same email message from your phone, it's not there because it's been downloaded to your laptop. IMAP4, however, can leave messages on the server. You can create folders on the server, and you can organize your messages on the server. So regardless of how you're connecting, via your PC or your laptop or your smartphone, you're going to be able to see the same repository of messages. You're not going to have some messages stored on this computer and other messages stored on that other computer. LDAP at TCP port 389, the Lightweight Directory Access Protocol, is going to be a way for us to query a common repository of usernames on the network, maybe to look somebody up, to make a phone call to that person, or to send them an email. And this LDAP server can also be used to authenticate us. I've asked my students about what LDAP server they use over the years, and I would say well over 90% of my students report using Microsoft Active Directory as their LDAP server. Think about it. With Microsoft Active Directory, you can have one account, and that allows you to log into your Windows domain. It allows you to access your email on a Microsoft Exchange server, and you can have several other third-party applications that are pointing back to that common repository of user information. So you don't have to keep recreating usernames on different devices. They can just all point back to the same device. Earlier we talked about HTTP and how it could allow us to surf to a web server out on the internet. If we want to do that securely, however, maybe because we're going to be doing some online banking as one example, we're going to be giving credit card information perhaps, we probably want to do that securely. And we can do that using TCP port 443 and a protocol called Hypertext Transfer Protocol Secure, RSH, or Remote Shell, running at TCP port 514. That allows us to execute a command on a computer even if we're not currently logged into that computer. We're a remote user. Next on the list, which could use either TCP port or UDP port 554, is Rtsp, the Real-Time Streaming Protocol. This protocol could communicate with some sort of a media server, like a video server, and it could allow us to give control information to that video server, such as we want to pause the playback as an example. And last on our list, I wanted to include one protocol that was not a quote-unquote well-known protocol. Notice its port number, TCP port 3389, that's greater than 1023. It's RDP, the Remote Desktop Protocol. This is commonly used on Microsoft devices to get a remote desktop session where you could control another computer remotely, maybe to help somebody troubleshoot an issue or to control your computer back at the office. One of the reasons I wanted to show you this was to point out that we can have protocols that are commonly used that use a port number that is greater than 1023. Port number 3389 is not a well-known port number. However, in actual practice, it is sort of well known. It's a port that a vendor has selected to use for one of their popular applications. And I wanted you to understand that you might run into that. You might have a commonly used port number for a specific service, for a specific application. Just because that number is not 1023 or less than 1023, it could still be the port number that everybody agrees they're going to use for that particular application. So to sum up, we've got a variety of applications that use well-known port numbers of 1023 and below. They might be TCP or UDP ports, they might be both, and we could have other applications that a vendor declares we're going to use this particular port number for this application, and everybody just agrees to use it even if it's not technically a well-known port number.